Hi guys, so welcome back here at the Easy Engineering Tutorials. So this time is we're going to solve a problem under beam deflection. So bali yung tinatanong sa problem is ano daw yung deflection natin dito sa free end at point C. So for a given beam, so we have an overhang beam loaded with 2 kips per feet for a span of EB, and dito sa span na BC meron tayong point load na 12 kips, no? So, yung dimensions are also given in feet. So, yung EI is held constant. Okay, so ngayon, yung gagamitin natin ng mga method is double integration method. We will also use the area moment method, the conjugate beam method, and the unit load method. Okay, so first solve natin to using double integration method. So bali ito yung problem natin, kunin ko lang. And then solve natin to using double integration. So first, we need to compute for the support reactions. So, bali dito. Support. Reactions, no? So, sabihin natin, we have this BY. Dito meron tayong reaction vertical and also horizontal, no? EX. So, by summation of forces along X equal to 0, so alam natin na yung EX is equal to 0, no? Kasi wala tayong load along X. And then by summation of moment at point A equal to 0, assuming na yung ganitong rotation is direction is positive. Okay? So yung ganitong direction is positive. So thus, yung mga forces dito sa point A is cancel out kasi dyan tayo mag-moment. So yung meron na lang tayo sa itong BY. So we have BY multiplied by yung distance niya, perpendicular distance, na, which is 30. And then we have itong 2 kips, so which is reverse, assume natin na direction. So this is taken as negative. So 2 times yung 30. So ito yung equivalent concentrated load nung 2 kips, na. So this is 2 times 30. Parang area lang nung uniform load. Okay? And then yung moment arm niya, which is at distance half nung 30. So we have 30 divided by 2. Okay. So next is itong 12, no? So again, that is reverse, assume natin na direction. So this is taken as negative. Then yung perpendicular distance niya to point A, that is 40. So pwede na nating equal to 0 kasi wala na tayong ibang load. Thus, yung BY natin is equivalent to okay, saglit lang guys. So thus, yung by natin is equal to, dito ko muna yung calculator ko. Alpha x minus 30 times 2 times 30. 30 divided by 2 is 12 times 40. Alpha equal to 0. Shift solve, so we have 46 keeps. Positive sign indicate na tama yung assume natin na direction. And then by summation of forces vertical equal to 0, so assuming positive yung ganitong direction, thus yung EY plus yung BY natin minus yung sa uniformly distributed load, which is 2 times 30, yung equivalent concentrated load niya. And we have also 12 kips dito sa free end. So wala tayong ibang force. Thus, we have value of AY. Okay, so alpha x plus 46 minus 2 times 30 minus 12, alpha equal to 0. So we have 26 kips. Positive sign indicate na tama yung assume natin na direction. So yung mga value dito is we have 26 kips, and dito sa BY we have 46 kips. So okay na tayo sa support reaction. So punta na tayo dito sa medyo ko lang muna to. Sa double integration. So dito sa double integration method, ayan. So meron itong formula, no? Yung EI nung second derivative is equivalent lang ng moment equation natin. So yung gagawin natin dito is dito sa beam natin, ito yung beam. Ayan. Okay. So pag mag-create tayo ng equation, as much as possible, makapture natin lahat ng forces, no, na dito sa na nag-act dito sa beam. So bali magka-cut ako doon na sa hindi naman doon sa pinakadulo, pero almost doon sa dulo. So bali ka-cut ko to dito. Then and then gawan ko ng equation ng moment dito. So I have this moment of x. Okay? So gawa natin ang equation yan. So bali yung mga forces na meron tayo dito is the first one is itong 2 kips per feet. Ayan. And aside from that, we have also itong 26 kips na reaction. And we have also this 46 kips na reaction. So since dito tayo mag-cut, so yung rule natin for mga varying and uniform load is pinoproject natin yan. So hanggang dun sa cutting section mo. So yung gagawin natin dito is i-extend natin to. Extend natin yan hanggang dito sa cutting section natin. Okay? So same magnitude, same direction. So this is 2 kips per feet. So same direction. Okay? So ngayon, itong 2 kips na yan, kasi dito sa actual beam natin is wala talagang walang load dito, di ba? Walang load dito sa actual beam natin, no? So yung gagawin natin is mag-a-add tayo dito ngayon ng same magnitude but opposite sign, no? So bali mag-add tayo dito ng another 2 kips per feet, but but opposite yung sign niya. So meaning, dito sa overhang na part is parang mag-zero pa rin siya, no? Or mawala lang yung load. Okay? So yung rule lang natin dito is need natin siyang i-continuous dun sa cutting section mo. So ganun, no? So okay na tayo dito. So gawa na natin ng equation to. So we have now yung moment equation dito, which is the first one. So bali at distance, yung cutting section is at distance x. So we have 26. Then yung distance niya hanggang dito sa cutting section natin, which is x. And aside from that, we have also this 46. So we have 46. And then meron tong distance na we know this one is 30 feet. So therefore this is x minus 30. So pag makikita ka ng ganitong term, yung mga x minus 30 or x minus a, no? Where yung a is any arbitrary constant. So dito papasok si makulay bracket. Okay? So we have this makulay bracket. Dito siya papasok, no? So sa mga term na to, nilalagyan natin yan ng makulay bracket. So anyway, yung makulay bracket na to is meron tong dalawang rule, no? So the first one, if yung value, no, nung term na within sa makulay bracket is negative, meaning disregard yung term. Okay? Disregard yung term. Pero kung yung sagot niya is positive, we need to consider it sa computation natin. Okay. Klaro, no? Sige. So we have 46. So ngayon, lalagyan natin to ng makulay bracket. So we have this 46 x minus 30. And then we have also itong 2 kips per feet upward. Ha? So we have plus 2 times yung distance niya, x minus 30. And then may moment arm pa yan, no? Patungo dun sa cutting section. So this is x minus 30 divided by 2. Then aside from that, itong uniformly distributed load na 2 kips per feet downward, no? Hanggang dun sa cutting section. So minus itong 2 kips, and then yung overall distance is itong value ng x. So we have x, and then we have x divided by 2, yung moment arm niya. Okay? So ito na yung moment equation natin. So pwede nating i-simplify ito. So we have 26x plus 46 x minus 30 plus we have x minus 30 squared and then minus x squared. Okay, so ngayon balikan natin to sa double integration. So we have this double integration method. So yung formula is EI, yung second derivative is equivalent ng moment equation. So which is itong 26 x plus 46 x minus 30 then plus x minus 30 squared and then minus x squared. Okay? So, ito na yun. Ha? So, to solve for slope natin, okay, so it is pertaining to moment. Na? So, next is yung slope. So, we just need to integrate. So, i-integrate natin yung second derivative, magiging first derivative yan. And ito magiging slope na. Okay? So, recap. sa calculus natin, so far, itong formula lang naman yung magagamit natin. No? We know that integration of un du is just un plus 1 over n plus 1 plus c. So, kung titignan mo, yung formula is itong exponent, we just need to add 1. No? Ngayon, itong exponent na to is ibababa natin yan dito sa denominator. So, ganun lang yung pattern. You just need to add 1 and then ibaba mo yung exponent. So, bali yung mangyayari dito is itong mga constant, ilalabas natin yan. So, this is 26 and we need to integrate itong x. So, itong x, may exponent 1 yan. Diba? Okay, exponent 1 yan. So, meaning magiging ano to? X squared and then yung squared ibaba mo. Next, yung 46, no? Again, ilabas natin yung 46. Ngayon, dito sa makulay bracket, you will treat this one as one term. Parang x lang, parang gano'n, no? As one term. So, this becomes, again, may exponent to na 1. So, bali mo plus 1 ka, no? So, this is x minus 30 plus 1. So, this is square. Itong square, ibaba mo. Ayan, no? Next is itong, again, may makulay bracket tayo dito. So, as one term lang yan. So, this is x minus 30. So, may exponent 2 siya plus 1. This becomes cube. And yung cube na yan, ibaba mo. Okay? And minus x, itong term na to. So, may exponent siya na 2. So, plus 1, that is cube. Then, over 3. So, meron pa itong constant. So, ito na yung equation natin. And for deflection naman, so, integrate natin to. So, makukuha natin yung ei, yung y. Yung y yung deflection. Okay? So, integrate natin to. Ilabas ko ulit yung mga constant. Itong 26 divided by 2. So, yung integrate ko na lang itong x squared na yan. Ha? So, I have x plus 1. Cube, ibaba mo yung cube. Next is itong 46 divided by 2. So, you have x minus 30. Meron pang ito yung integrate natin. Ha? So, may exponent ka na 2. So, plus 1 is 3. Ibaba mo yung exponent niya. Next is itong again, ilabas mo yung constant. Then, we have x minus 30. So, meron kang plus 1. So, 4, no? Then, ibaba mo yung 4. And then, you have x cube. So, that is x to the power of 4 plus 1. Wait lang. Ilabas ko muna yung constant. So, you have x 4 over 4. And then, you have c1x plus c2. So, ito na yung equation natin. So, ngayon, para ma-solve natin yung mga constant, c1 at c2, we will use boundary conditions. So, dito sa boundary conditions, usually yung ginagamit natin since sa support, walang deflection yan kasi lalo pag hindi provided na may support sa internet. So, walang deflection. So, doon yung pinakamagandang gawan ng or kuna ng boundary condition. So, bali dito sa point A. So, may x yan na 0. Itong point A. Support A. And then, may deflection yan. Kasi support yan. So, meaning, wala din siyang given na support signal. So, that is equal to 0. And then, yung point B naman, so, wala pa rin tong settlement. So, meaning, pag mag-deflect yung beam, 0 yan sa point B. Okay? So, at point B, so may x yan na 30 feet from A. So, this is 30 feet. And then, yung deflection niya is 0. So, substitute natin ito dito sa equation natin sa deflection. So, we have EI, yung y 0. So we have 26 divided by 2. Then this is 0 cube over 3 plus 46 divided by 2. So we have 0 minus 30 squared divided by this is cube divided by 3. So ngayon, balikan natin yung makulay. So sa makulay bracket, if negative yung sagot ng term na andyan sa makulay bracket, i-disregard. Pag positive, consider. So dito kung titignan mo, yung 0 minus 30, this is a negative 30. So meaning itong value na to is negative. So meaning itong term na to po, you need to disregard that one sa calculation mo. Okay? Next. So, plus 1/3 ng 0 minus 30 to the power 4 over 4. Again, itong 0 minus 30, this is a negative value. So, meaning yung ito lahat is i-disregard. Okay? So, disregard. No? Next. Minus 1/3. Yung x is 0. So, 0 to the power of 4 over 4 plus C1 times 0 plus C2. So, thus, C2 natin is equal to 0. Okay? Kasi kung titig naman dito, this one is 0. Ito din 0. Ito din 0. So, ito 0. So, C2 is 0. So, dito naman, sa pangalawang boundary condition, so we just need to substitute again yung 30. So, we have EI, yung Y is 0. And then, we have 26 divided by 2. So, yung X is 30. So, 30 cubed divided by 3 plus 46 divided by 2. So, we have 30 minus 30 cubed over 3. So, kung titignan mo dito, 30 minus 30 is 0. Hindi siya negative. Hindi din siya positive. But anyway, 30 minus 30 is 0. So, bali ito lahat is equal to 0 pa rin. No? Okay? Next. Plus 1/3 nung 30 minus 30. This is to the power 4 divided by 4. So, 30 minus 30 is again 0. So, bali, number multiplied by 0, 0. And then, minus 1/3 ng 30 to the power 4 over 4 plus C1 times 30. Yung C2 is 0. So, thus, masolve natin yung value nun C1. So, using calculators, we have 26 over 2, 30 cubed over 3, minus 1/3 ng 30. Computing ko muna. To the power 4, plus 30 x, should solve. So, yung value dito is negative 1650. Okay? Okay, so ngayon, meron na tayong equation ng elastic curve. Okay? So, may equation na tayo ng elastic curve. So, we have EIY, which is equivalent to 26 over 2 x cubed over 3 plus 46 over 2. This is x minus 30 cubed over 3 plus 1/3 ng x minus 30 to the power 4 over 4 minus 1/3 ng x 4 over 4. So, may value na tayo ng C1. This is negative 1650 alpha x, C2 is 0. So, ito na yung equation ng elastic curve natin. So ngayon yung tinatanong is ano daw yung deflection at the free end. Okay? Ano daw yung deflection sa free end? So meaning, ano daw yung deflection when x is, so yung x natin dito sa free end is, di ba, from 0 to 40. So 40 feet. So ato, i-substitute lang natin yan dito. So we have EI, ito yung tinatanong yung y. So this one becomes 26 over 2, 40 cube over 3, plus 46 over 2. Then we have 40 minus 30 cube over 3. So take note, itong 40 minus 30 is positive 10. So meaning, we need to consider this one in our calculation. Next. So at is yan, andyan yan. Plus, 1/3 ng 40 minus 30 to the power of 4 over 4. So again, yung value dito is positive. So we need to consider this term sa calculation natin. Next. Minus 1/3 ng 40 to the power of 4 over 4 minus 1,650 times 40. So we just need to calculate that one. So we have now the value of y all over EI. So computing ko muna. 26 divided by 2 is 26 divided by 2 and 40 cube divided by 3 plus 46 divided by 2. 26, 46 divided by 2. And then we have 10 cube over 3 plus 1/3. Again, this is 10 to the power of 4 minus 1/3 ng 40 to the power 4 over 4 minus 1,650 times 40. So yung value natin is 6,500, and this is a positive value. Okay, so ngayon may convention itong deflection, no? So pag yung makuha mo dito, yan dito, yan, so may sign convention yan, ha? So yung sign convention dyan is pag yung makuha mo is positive, ibig sabihin nun that is an upward deflection, no? And pag yung makuha mo is negative, meaning that is a downward deflection. So since yung value natin is a positive, meaning this is an upward deflection. So ngayon, if i-draw natin yung elastic curve na to, draw natin yung elastic curve dito. So ito yung magiging itsura. So 0 yan dito, 0 dito, no? And then dito is upward. So parang ganito. Ayan. So ito yung upward deflection, meaning this is above x. Okay, above x. So yung deflection dito is 6,500 all over EI. Okay, klaro? See. So sa next na video, we are going to solve this problem using area moment method. Okay, thank you.